what are we up to today? Well, we're playing with mains electricity, as you've probably gathered by this pile of stuff. Now, before we say anything else, okay, I'm not even going to give you some tips and trade secrets and whatever on this. Just don't play with mains electricity, okay? I don't want to be responsible if you electrocute yourself, and it's very easy to do. And if you're inexperienced or unqualified, you can and probably will electrify yourself to some degree. So just don't do what I'm doing today. This is just for curiosity. Now, just in case anybody questions my qualifications to do this, I'm not an electrician. I am certified to do test and tag, however that doesn't qualify you to do mains electrical stuff. Secondly, this is not installed in a house, this is on a desk, and everything is protected by overcurrent protection and leakage protection, so RCDs and circuit breakers. That I have tested. According to my training, I am qualified to test and tag safety devices like that, and I'll be going over the maths about the current loading. So if there's any qualified electricians watching this, you'll see that I've done my maths very carefully, and I will be getting a qualified electrician to check my work off camera as well. I do know several, so I'm making sure this is done safely, so don't get on my case about it. Alright, disclaimers out of the way. Let's see why we're playing with mains current. So, this computer up here this morning had a catastrophic failure. I went to push the button, it went kazap, little puff of smoke, stopped working. So, what I ended up doing is I did actually have a spare power supply, which is a proprietary one, very particular, big fat connector on the end to connect all the leads to it, because this is a Dell T3500. I've put extra RAM in here. I've got 16 gig of RAM in it, and I've got an X5650 processor in there. It's a 6-core with hyper-threading. So my main workstation, basically, it just would not work. I've replaced the power supply, I replaced 2 of the RAM sticks, and I got it back together. What I reckon happened is that the power supply failed and went over voltage, and over voltage killed a couple of RAM sticks. I'm pretty sure that's what happened to the last one of these I've got. So we swing around over to the edge of my desk here. This is my common use power board. It's just blue tacked down here, and you probably see the neon flickering with the refresh rate on the screen a little bit. This port here has already died, and this one was the one that my main workstation was plugged into. It's now died and was making intermittent contact. That is because of the way they design these boards. They're made in China, and instead of having 2 rolled pins like they used to, they have a flat bar that they twist, and then when your pin goes in, it pushes up against the edge of that and just grinds in that way. If there's any kind of a problem, this little junction here zaps out and it starts getting loose and making intermittent connection. Or if you plug it in wrong, it pushes that down and bends it. It's just a horrible design, and I cannot find a power board anywhere, save for Jackson branded stuff, that doesn't do this. And I can't find Jackson branded things. So the way I'm fixing this is I'm putting in several of these. Now they need to be wired up, they're wall points, so I have the correct electrically rated mounting block, and they will be mounted on a 4x2 pine, electrically insulated. Now this board piggybacks off another power board. Now there's an old wives' tale that says piggybacking power boards is a bad idea, and that's true to a degree. In this case, the main power board that all my other power boards come off has overload protection and RCD protection. Now the overload protection is done in series, so provided I go off that one central board, the total load is still going to trip that. I'm not going to be bypassing the overload protection in any way doing that. On top of that, everything runs off a UPS, which itself has the same protections, and it starts screaming at me if I exceed 1100 watts, far below the 1200 watts, or sorry, the 2400 watts that is rated for the single power point that runs everything on my desk. Now let's move over to the next bit here. Over here we see I have a Belkin power monitor. The entire load of this entire desk runs through this monitor, so I can see if I'm exceeding any power usage here as well. And as you see, on a typical day, with most things running, I'm only pulling about 300 or 400 watts. So we're pretty well safely in our rating to do that. Let's go over some of the stuff we've got. Now, I have the heaviest power lead that I could find in my collection, short of buying some heavy lead off the shelf at Bunnings. And of course, I couldn't find anything bigger than 1.5 mil anyway. So for the 1000 watts or so I'm going to be pulling through this should be fine. But our power plug is not compliant. And if you're not sure why, I can recommend a good website to find that out. But crucially, it's down to the little black bits on here. Now, I wanted a right angle plug on this anyway, so I bought a brand new one that is compliant. And you'll see here it has the black insulators on those pins. That's just designed so that you can't get your finger stuck in behind here and zap yourself when you're still half plugging it in. You can see that's about the width of my finger. That and things like Venetian blinds and stuff getting stuck in here. This won't be too much of a problem. It's going to get plugged in once and left that way outside easy reach. They do have the nice cable gland in here too. I'm happy to see that. That's, I think, for figure 8 cable. Alright, and I have some proper 2.5 mil rated building cable. I'll be using that to interconnect all of these boards, and I'll be doing it in such a way that it's not accessible. Normally you should put this through conduit, but what I'm going to be doing is going from one board to the other out the side of these, and these will be butted up against each other so the cable is not accessible in the slightest. So I'm trying my very best to comply with AS 3000 and AS NZS 3760 standards, because I will be getting somebody who is certified to actually check all this, and if it's not right, I'm going to have to rip it out and start again anyway. So yeah, and I'm actually paying for that privilege too. Anyway, first of all, I need to shut down everything that's plugged into this, and once that's done, we'll be able to start organizing what we need to put and where. Alright, so I've elected to do a little bit of preparation work first, and the first thing I'm going to do is cut out some of these galleries. These little galleries are designed to be snapped out with electrician's pliers and to fit the right diameter for conduit. Unfortunately, we just want to do this, so we're going to come in just a little bit less than normal. I'm going to use flush cutters facing this way around, and we're just going to get them to about the right width here. So we don't want sharp edges or anything like that. Once we've got that, we're going to get a pair of pliers here, and we're going to bend and snap. A couple of repetitions, that'll come out, and if I've done it right, I'm a little bit narrow, but I'll trim that out just a little bit more, and we're pretty well there. Be nice and square and not too much slack, but not so much that when I screw everything down that it squashes the cable and causes an insulation breakdown. And I'll be doing the same at the other end of one of these for that incoming power cable. But alright, I'm going to get cracking on these. Now, the next bit of it I can't access unless I'm outside, so I have to adjust my curtains and wind them up automatically. And judging by the way that one's slipping, I'm going to have to make a new drive cog for that soon. Yeah, it's really slipping. Anyway, we'll wind these up till I can get access to the window, and we'll secure some stuff. Alright, it's time for a drink. I've had to put in the last 8 of these with one of these because I failed to realise that I don't have enough room between the window and where I want to put them for a cordless drill. And yeah, and this desk is not going to get moved at this point. I went in without anything on it, now it's probably got about 1.5 tons of stuff on it. So, and in the case the mounting blocks are mounted, I've got a little bit more to do yet. time. It's time to do the power lead. I had to stop while I grab all my tools for a minute, but we really only want this for the cable. Now I need to work out how far away this is going to be. I'm probably going to need the full length, I think. Probably just. Alright, so well, I would like to salvage the IEC connector. They're like rats, I have heaps of them. Now another little tip to the end of the cable that you use for the plug, it does matter because the direction of the flip. And something else I should mention too. You'll notice that there's these little covers over the power points. That's because there's a standard in the AS3000 standards that means that you can't have any exposed metal parts. One of the reasons was power points were attached with these screws on plaster walls, and the screws, or drywall if you know it, and they would go all the way through into a metal plaster hanger, which on the rare occasion could contact a piece of uninsulated wire. I mean, if things are done horribly wrong, that's possible. If they're done right, that really isn't. But that could mean that there was then an exposed live part available at the front of the power point. So the solution was pretty much either to put little plastic caps in the holes or to put a facade like that over the top. But anyway, this is our plug end. So we're going to do our plug in a moment here. I'm going to strip this. I would use these automatic strippers, but in my experience that's a bit of a problem. We're going to open this bag and show you how to use the measuring guide. So we have everything stripped off and laid against here, and we're about right. So this is an old standard cable. That's my neighbour who thinks he needs to be at 100 kilometers an hour in the 150 meters it is between here and his place. Anyway, this is old standard. This has got brown and blue, whereas this current standard is red and black. And black and blue is what you'll be if you get this wrong. Namely that black and blue are both neutrals and red and brown are both positives. That's how I remember it. If you're black and blue, you got bruising, it means you got it wrong. So, alright, let's wire this plug up. One of the things I like about these right angle plugs, instead of the frustration of having to get those rubber shrouds off, of which I have done many of, this has two screws. Now we need a proper flat blade screwdriver here, and I have a properly sized one for that job. The correct size screwdrivers for a job is an art all of its own, or a discipline I would prefer. It's not an art. There are absolutes, there are no in-betweens. Right, and these screws have a little stop on the end of them where the thread stops, so you don't actually drop this terminal all the way off. Now our green painted screw is our earth screw, but when it's mains voltage I like to double and triple check and just think of myself as a bit of an idiot. But it says here green yellow stripes for all green, and the terminal is marked E. So this one is painted green, and it should be marked E, and it's the vertical pin. So yep, we know for sure that's an earth pin. So let's get this in here, and we'll do all three of these and we'll be back. In normal inline plugs there is actually a special way that the leads have to go to provide strain relief. In these ones it's a little different. The strain relief is provided by the mechanical clamping force of the rear of the cover. So we'll get all this in. Now you'll probably notice from the documentation here that little black thing that I mentioned before, that's if you're using 2-core flex, like lamp cords and stuff. One of the reasons I like these transparent plugs is it's very obvious if something's gone wrong, such as if you've lost your earth lead, which is something that's not readily apparent. Things will continue to run, but it's not anywhere near as safe to continue running them. Happens a lot on vacuum cleaner cords in office buildings and stuff, where people use those backpack vacuum cleaners with very long leads, and they always roll them up the same way and never unroll the twists, so the twists just continue to build up, and usually the wire that gets shortest first is the earth wire, and it pulls out. And you'll notice from the side here, everything's these 3 clamping units here, or little bulkheads, I guess you could call them. They're pushed in very firmly against that cable, and that's providing very good strain relief. So it's done up nice and firm, and we can see our cores up there. I'll be putting my test and tag machine on this before I use it too. Just making sure that all the phases are correct. Or sorry, not the phase, the polarity, I guess you could call it. It's not really polarity when it's AC, but when everything's connected in the right spot. This is what you get when you do unscripted stuff. You sound like an idiot sometimes. Anyway, this end we've got to wire into the board, which means I've got to poke some stuff around. I'll be back. Okay, well, I've got all three of these blocks wired in, and I'm just dropping stuff on my feet everywhere, getting tangled in things. I'm just shutting down my machine here. I'm going to make a key change, but it's almost getting time for a break. I'm getting hungry and irritable and wobbly at the legs. You'll see this RCD hanging out the back here. This connects to the main board up the top, that everything's piggybacked off. There is a second output on this, and I'm thinking it's probably, now that I'm increasing the number of points, it would probably be wise for me to use the extra output from my UPS directly. But I lose the RCD protection that comes with that power board, but I won't be using def leads anymore. But it does spread the load out a little bit better. So we'll be doing that. We've got the lead here. We'll plug that in a moment. Plug changeover is complete. I've had to jack it up on blocks so that I could fit that in. One day I'll make a short extension lead to fit that. But there's our angle plug fitting in there. Nicely out of the way. So now I have to put all my stuff back on this drawer, and I need to find my my tester as well, so I can check all the relation to ground and make sure I've got everything wired properly. Alright, I've opened one of my many bags of gear, and I've got a phase rotation sensor in this one for checking 3-phase motors, and I've got an RCD trip time tester. Crucially, it has the neutral, what's that, the line to neutral and neutral to earth, or line to earth relation on here. If both those lights don't light up, I know I've got problems. And I can trip the RCD with this as well by attaching a variable amount of load across ground from active. And I can also have it trip at certain points in the phase as well. Handy bit of gear, but I'm going to go plug into each segment and make sure it's wired properly. Make this quick because the ants are biting my feet. Let's turn this on. Alright, I don't know if you can see from here. I've got two lights. That means that side's wired properly. That's on the end of the chain. It means they probably all are. Yep, that one's wired properly. And it looks like number 3 section's wired properly. Alright, let's go back inside and get away from these ants. It's almost time for a break, and I've got to clean up all this mess that I've made. This desk was nice and clean before I started. And I need food, I need a break, and I need to give my Sparky mate a call and tell him I'm done with this bit, and see if he'll drop around and check everything for me. So, we'll be back. Well, I was just in the middle of editing this video, and I was about to jump to the last bit, but I thought I'd insert this video in now. I'm going to do a quick tear down of this board and find out exactly what's going on in there, and if I was correct about my assumption about the strips and whatnot in here. So let's get a snake eyes driver bit and pop this thing open. This is for the record, this is a snake eyes bit. It's dexterity's not great right now, but we'll pop all these screws out and we'll jump to the bit where I've sworn at it 100 times off camera. We'll be right back. Most of our screws out, and a couple still sitting in the galleries, but we'll just lift the back off. This one is a bit deeper than I expected. Alright, I think that's all of them. Okay, so this is a little different to what I'd expected. Let's bring our camera around and have a look. Alright, so we do indeed have some surge protection going on here. And yes, we certainly have some pins in here, but geez, they're made horribly. And we've got a flat. This is the earth pin connection, which I think that looks like that's made fairly well. We have, of course, our circuit breaker here. They look very similar to the 12-volt ones, actually. And we have actually properly rated switches in here by the looks of things. But these little terminals are the bit that I'm interested in. I think some of these are bent. I'm going to pry that out and have a look. Right, now this is definitely a very cheeky way of making a contact. They've punched it out of a single sheet, and there's not actually a whole lot making contact when they do this. They're very easy to bend. So you can see here, yeah, it is trying, they're trying hard to come up with a cheap way of making it gain a bit of surface contact area, but yeah, it's really not. So I think the socket that actually failed on this was one of the endmost ones. I think this one here. Yeah, we can see here that's bent out of place. So this is what I really think causes fires and damage to electronics, is when they have crappy pin connections like this. Yeah, I think that one's bent out. When you look at, and you see here, this wasn't bending by me. I think this might be heat affected. I'm not sure. They've soldered them on. I seem to recall somewhere that soldering on main stuff is actually a bit of a no-no. I think because it can vaporize and flash over. I don't think that actually meets standards. I'm not sure. I'm going to have to look that up. You know, I'm on YouTube, so there's going to be about 100 experts are going to correct me, but I'm not sure that classifies. I really don't. I remember somewhere along the lines when I was doing, I was way back in school learning about this stuff, that yeah, solder on main stuff was a bit of a no-no. That's why most of the power points and stuff like that all have screw fittings. But I am going to give these a little bit of a squeeze first and see if it cleans it up. But yeah, I just wanted to have a quick tear down and have a look at this. There's the an MOV board, and it's got a nice little filter or choke in there, which is interesting. I'm not going to rip that off. I think the MOVs are fine. And the surge protection on here, I would have expected a gaseous arrestor, but it's literally just another couple of MOVs on the network protection, with no, there's some labeling there. I'll have to look that up and find out what voltage they are, but that's dumping that down the ground line. So I don't think I'd like to connect my my network to that, actually. I don't like the idea of having a direct connection to mains ground available on a low voltage network cable, especially if sort of something went wrong on this power board, which apparently is quite possible. Alright, we'll see if we can do anything with this, but yeah, let's get on to the end video of this. I just thought I'd take a little cut in here and dissect this board. Alright, back to the usual programming. Alright, I've got my desk fully lit up, and I've got everything cleaned up. And my Sparky's been, he's had a look, and he had a couple of concerns, but he said electrically everything's fine. But he did make a remark about the way I've got things piggybacked, and he said I really probably shouldn't be doing a combined total load of more than 2400 watts, which is something I already knew, which is why I have this little watt meter up here, which we saw earlier, and I'm currently drawing 344-ish watts. And so yeah, it's I've got a lot of little loads, like, you know, milliamp loads, and sort of, you know, tiny little like 10, 20, 30 watt loads, and I've got a visitor apparently too. But yeah, I just needed lots of plugs, but not a huge amount of current, so we're doing pretty well. I'm not exceeding the limit anywhere near that. 300 watts is a long way from 2400, but it's spread out fairly evenly, and he's actually happier about the idea of running 2 ports back from the UPS instead of piggybacking powerboard after powerboard, which is, I'm uncomfortable about that too, to be honest. But I have reclaimed some desk space. I've got 15 points along here for all the little things and the plug packs and stuff. Yeah, so I'm pretty happy with it. My main machine is running a lot more stable now too. It hasn't had any of its usual little quirks that it's been having, so I think this power issue has been a problem for a while. But anyway, I'm pretty happy with it all. We'll see you all in the next one.